Okay, so for page 2 of your notes from the exploration packet, we are doing the up and down transformations. So these are the same tables that you saw in Desmos. These are the same graphs that you saw in Desmos. So we're going to highlight and use our color pens the same way we did in class. So we'll start with the parent function, which is the square root of x. So we'll highlight that in whatever color that you like. I don't really care, so go ahead and highlight that for me, please. And same thing, you're going to highlight the graph that it belongs to. And then right above the f of x part, you're going to write, or to the side wherever, you're going to write square root of x. That's the parent that we're starting with. Now this one right here, f of x plus 2, we're going to take the square root of x. On the outside of the radical this time, we're going to put our plus 2. So notice the positioning is outside of the radical. And so you'll notice that all of those x values remain the same. And so we know from class today that this plus 2 on the outside is going to make our graph go up 2. And so therefore the y values are going to be 2 higher than the original y values from the parent. So we're going to add 2 to your y values. In a different color highlighter, you are going to mark the graph that is associated with. And so that's going to be these new points here. That's going to be your shifting up 2. And that's going to be this table that goes along with it. We're going to color code that and highlight. Okay. And then the last one that we have, this last table is saying to take the parent function square root of x and subtract 3 from it. So right above there, we're going to write square root of x, and then on the outside of that radical, we're going to subtract 3. So that's going to be affecting your output. And so you'll notice that all of your x values are the same when you compare it to the parent function, but those y values are going to be 3 less. So we're going to make a mark from the original y values for the parent function to the new ones here on the transform function. And this time is subtracting 3, just like it says there, from those y values. And that subtracting 3 from the y is what's going to make our graph shift down 3 units. So now we're going to take our third color highlighter and we're going to highlight that section of the graph along with the table that it corresponds with. So this is going to be for your tables and your graphs, the difference between moving up versus moving down on a parent function. Now we're going to go to your notes in the color box, or the box, and then we're going to do an example. So in the first line, if we have f of x plus d on the outside and d is positive, that means we're going to add d units to the y values, which means this graph is now going to go up d. So we'll write that in. So shifted up d units. To make that happen mathematically, you're going to go to the table. The corresponding x values mean where those x values are the exact same. We're not going to mess with them. We are going to add d to the y coordinates. And if you have your new function to be f of x minus d, the parent function f of x is actually going to be shifted down d units. We saw that today in class. And in the table for the y value, the x values that are the same, we're going to subtract d from those y coordinates. And so we have an example. This time our parent function is your absolute value of x. And so we'll use that to show these transformations for up and down that we were talking about. So absolute value of x, you can plug in whatever numbers, just like we talked about in class. I don't care what they are. So let's randomly say we plug in 0. The absolute value of 0 is still 0, so I'll plot that 0, 0. If I choose to plug in 1, absolute value of 1 is 1. And so now I have 1, 1 as a point on this graph. If I plug in -1, the absolute value of -1 is still 1. So I'll plot -1, 1, and then so forth. I'll do the same thing for -2 and 2. And the absolute value of both of those is still going to be 2. So now when I go to graph this, I'm going to have a V-type shape. Obviously, my graph is a little bit off, but you get the idea, okay? And then a different color pen, I'm going to do h of x plus 3. I know from our lesson from today in class that this is going to take my graph and move it up 3 units. And this h of x, if I replace it with the square root of x, is going to be the square root of x plus 3. So this is really what my equation is. And so now, remember, we're going to leave all those x values alone. So since it's moving up, the x values are not going to change. And it's only the y values that I'm going to take and add 3 to them. So 2 plus 3 is 5, 1 plus 3 is 4, and then so forth. I'm going to plot those points for my new graph, the transform graph. These are a little bit off, but you get the point. And so now when I connect that, you'll see from the blue parent function to the green transform function, this graph truly did go up 3 units. Now, I asked you to do slides 21 through 26 for homework. So these are going to be more transformations again. And so these are going to be your reflections over the x or the y axis. So let's go back to our 3 color highlighters. And the parent function is still the same, square root of x. So I'm going to highlight that one along with its table that it goes with. I'm going to write square root of x above the original f of x or beside it. So that's still square root of x. The negative on the outside of the f of x means I'm going to take the original square root of x and I'm going to put a negative in front of the radical. And then for this one over here, I'm going to take the square root of x, but where there was an x, I'm going to replace it with a negative x. And so now you'll notice one has the negative under the radical and the other has the negative on the outside of the radical, and they do different things. So if you look at these table of values from the left to the right, the parent to the new one, you'll notice that the x values actually remain the same. And it's those y values that are changing. So you're going to make an arrow from the y values to the left to the y values to the right. You don't have to make that first arrow. I'm actually going to erase that so you don't make that arrow. We're going to say that this is a reflection over the x-axis, because you'll notice that all of those y values have now become negated. So we're going to write negate the y values, or take the opposite of the y values, however you want to write that. So I'm just going to write the word negate y values. And if you leave all those x's the same and just simply negate the y values, 0, 0 stays where it is. 1, negative 1 is going to come to the 4th quadrant. 4, negative 2 will come into the 4th quadrant, and so forth. So I'm going to take another color highlighter and I'm going to highlight the function that get reflected across the x-axis. And that's true whenever you take a negative on the outside, it's affecting the output. So therefore all of those y values have been negated, and this is reflection over x. And so I'm going to write that above negative square root of x. This is a reflection over the x-axis. Now, for the third table, when we're making the x's negative, you'll notice compared to the first table to the third table, that now instead of those y's being negated, you'll notice that the x's have been negated, because this time you are affecting the input. You're negating those x values, and those y values remain the same. So when you go to plot those, if all of those x values become their opposites, negative 1, 1 now is in the 2nd quadrant, negative 4, 2 is now in the 2nd quadrant, and so is negative comma 3. So you'll notice this table of values takes all of those x values and makes them negative. It leaves the y values alone. And so now we have a reflection over the y-axis. So I'm going to take my third color highlighter and I'm going to highlight that graph along with the table that it belongs with in order to color code them. And I'm going to write reflect over y to make a note to myself. Okay. Now when you scroll down, you've got some parts of your notes to fill in. So the difference between negating the outside output versus the inside input is going to be the difference between a reflection over the x versus a reflection over the y. And so we want to look at the two of those separately from each other. So in the first line, if the function is y equals negative f of x, we know that this is going to reflect f of x over the x-axis. So we're going to reflect over the x-axis. Because it's affecting the y values, you're going to leave the x values alone, and you are going to negate the y values or make those y values their opposites. And that's what this negative on the outside is saying to do, make those y values negative. However, when you take the input and you negate it, you're making all of the x's negative now and leaving the y's alone. You're actually going to reflect it over the y-axis. All the x-axis values are going to be negated for all of the y values that are the exact same as each other. So where the y values are the same, you're just going to simply negate those x coordinates. So if I do an example, 2 to the x, this is one of your exponential functions. It's your parent function that you did in your book from page 6. So 2 to the x, let's put in whatever values of x that you want in there. For example, I can plug in the number 0. 2 to the 0 we know is 1. I can plug 1 in there. We know 2 to the 1 is 2. I can plug 2 in there. We know 2 squared is 4. So I could plot those. I'm going to put in a couple more points. Let's plug in maybe -1. So 2 to the -1, you may have forgotten what that does from Algebra 1. If you've forgotten, not a big deal. This makes this a reciprocal, so it now becomes the same thing as 1 over 2 to the +1. And so now this y value that pairs with -1 is going to be +1/2. And then I'll do the same thing for -2. That's the same thing as 2 to the -2, which is the same thing as 1 over 2 squared, which is 1/4. And so now I have some points to graph. I'll go ahead and do that now with one of my color pens. And then when you do your -2 and -1, you just get them kind of close. I know it's kind of hard to plot both of those, but you'll just get them close to the x-axis. And so it's going to look something kind of like that. Now an exponential is going to rise on the right-hand side for 2 to the x. And then I talked about it in the video from page 6. This is going to have what's called a horizontal asymptote at the x-axis. So it's actually going to start to flatten off as it goes farther and farther into the negative values. So there will be no points in the third or fourth quadrants. It'll just be everything in the first and second quadrants. So now this -x right here, we know that is going to be a reflection. More specifically, it's going to be a reflection over the y-axis. So in order to write the equation of that, it's going to be 2 raised to the -x. That's really what the equation now becomes. And so in order to make this transformation happen, I should be using a different color pen, but if you don't, it's okay. So I'm going to take all of these x's and I'm going to negate them. So that -2 becomes +2, that -1 becomes +1 all the way down. And those y values are going to remain the same, so I'm not going to do anything with those at all. So now I'm going to have a reflection over the y-axis. You're going to plot these points. Please excuse my handwriting. I am so sorry. I'm trying my best here. And when you plot these points, you'll see that you have your reflection over the y-axis.